Smart cities are enabled by technologies to serve communities better. In today's technological era, which is dubbed the fourth industrial revolution, we hear of developments such as software as a service, platform as a service, infrastructure as a service. But have you heard of seismic resilience as a service? Well, that's one of the innovations that's emerged out of the Smart Christchurch program. And today we have with us Grace De Leon and Michael Healy, the innovation leads of the Smart Christchurch program, to talk to us about seismic resilience as a service, EQRnet. So Grace, what is EQRnet?
So EQRnet is Seismic Resilience as a Service. So the background for this project is we have a lot of new buildings that's been built here in Christchurch, but a lot of them were descoping accelerometers being installed in their buildings because of the capital outlay. So being in the Smart Christchurch program, we have to think of a new approach, an innovative approach to this challenge. And we have come up with EQRnet, which is Seismic Resilience as a Service. So with this, instead of having capital outlay in purchasing the sensors, we actually provide it as a service. The Christchurch City Council is an anchor user, so we have 150 earthquake monitoring sensors now installed around the city. So there are 80 installed in traffic signal cabinets in the Christchurch CBD, about 30 installed in council facilities, and another 40 installed in pumping stations. So if there is a seismic event, these sensors are triggered, and it sends notification to the building warden if the building is safe to be occupied or it needs to be evacuated.
Michael, you might be able to shed some light on why EQRnet and why is it important for a city like Christchurch?
Yeah, well, I mean, it's well known that Christchurch has been through a series of, devastating earthquakes over the past 10 years, and we're well and truly in the throes of recovery now. But one thing that you would have noticed at the time of the earthquakes, every earthquake is different, and there's a lot of factors feeding into how it affects the building. So there's the standard that the building has been built to, there's the ground composition, there's the depth of the actual event, and a whole range of other factors that feed into the effect on a building. So no two earthquakes are the same. So this system gives us the ability to quickly assess whether a building is safe to be in and to see if the repairs need to be done or whether we need to do a detailed engineering inspection. Mm-hmm. So I think the real-time nature of it is key, and it gives people confidence that it's safe to be in a building, which is kind of key to keeping city centres running when you do have medium to large events.
So how is EQRnet different from GeoNet?
So GeoNet is an application that's widely used in New Zealand that tells us the shaking from the epicenter. So it doesn't tell us how that shaking affects the building or the exact ground shaking in a particular location. So if you are far from the epicenter, it could vary widely, street by street, building by building. While EQRnet could actually tell you the effect of that particular seismic event, because on the EQRnet we have data that is being loaded about the standard design of that particular building, so we could monitor what is the effect of that particular seismic event in that building. So for example, the Kaikoura earthquake in 2016, which is Kaikoura is the epicenter, but the badly affected one is Wellington instead of Christchurch, and Christchurch is near to Kaikoura.
And given EQRnet is underpinned by sensor-based technologies, can sensors actually give us a good indication of how bad the damage is on the building?
No. It would give us an indication on what is the impact of that particular earthquake to the building, because it would automatically compare the standards that's been loaded in the system. So in the past, what they do is actually gather historical data, but this time we have it in real time, and it will provide us the output straight away within 90 seconds.
Is this product in production at the moment, or is it part of a prototype or trial?
For this one, we are doing a 3-year trial. So during this 3-year trial, the Smart Christchurch program is paying for it. This enables us to transition it smoothly to the business, because what we think is that if we presented this product to the business will just, like I said, we don't have budget for it. But if we slowly get this to transition and prove to them that there is a benefit for having this product, this one now is being put into the long-term plan. So the budget for it. So after 3 years, the business is going to start to pay for.
Yeah, and I think the other thing too, it's important to get other users. So we're talking to private business owners in Christchurch about signing up to the service as well. So you've got large shopping centres and developments that have been built since the earthquake that could really benefit from the technology. And we're also talking with other government departments. So Ministry of Education, for example, we think would be really useful to sign up to service for them. So after an event, they can tell whether schools are safe to occupy, and it can give confidence to parents and students as well. So we think there's a range of different users that could benefit. And so we're contacting them, telling telling the story and seeing if we can get more people signing up to the service.
And do you see the potential of this particular application and prototype being applied in other cities across New Zealand, given pretty much most of New Zealand sits on that earthquake belt?
Yeah, so we talked to Napier and Hastings recently about our experience, and they're in discussions with EQRNet currently to see whether it's something they could have locally as well. But as you say, it's a very seismically active country, so there's probably no place in New Zealand that wouldn't benefit from it.
Yeah.
And the other thing then as well, overseas, especially around the Pacific Ring of Fire, plenty of opportunities for other countries to utilise the same approach as well.
And is this, the deployment of this particular application, is this changing the narrative in Christchurch, particularly with those residing within the city limits? And I'm thinking particularly around insurance providers and risk managers.
Yes, we're really changing that narrative from seismic risk to seismic resilience because we have that real-time data that is available that can be utilized in ensuring that, for example, for civil defense emergency management, when they look at it, they can deploy their resources accordingly instead of in the past, well, there is an earthquake and it's probably in the east that's mostly affected, so let's put them there. But now this product enables defendable decision making.
Yeah, and minimising the economic impact of events as well. The centre of Christchurch was shut for many months, which costs tens, if not hundreds of millions of dollars to the economy. So it's key as well, if you can target which buildings you do have to shut down or assess and get people out of, and then keep other buildings open, you can ensure that continuity of business and of people's lives with coming to work, being able to shop and whatnot. So it's really important to have continuity after an event as well. And again, but you're making good decisions using data. And
it's not just for when we have a big event. Sometimes you have an event and building owners do not know what they need to do. So they evacuate their staff and say, stay there, and then let's wait for the engineer to turn up and then do an assessment, which probably would take sometimes hours, if not days, to actually do. So you're losing about a day of productivity, which is costly.
Yes.
So with this system, you don't have to do that. You know exactly whether your building needs to be evacuated or it's safe to be occupied.
I heard a recently cited figure that if the city of Christchurch was shut down for a day, that would cost about $3 to $4 million. And the same extent to a city like Wellington shutting down would cost about $8 to $9 million. So this is, I think, a fantastic opportunity to deploy a product that could help, building managers get real-time information as to the extent of damage on the building given an earthquake. So any early lessons learned with this trial? Things that you would do, things that you would not do if you had to repeat the exercise?
Well, one of the learnings that we do is really working collaboratively with the other units of the council, because we have saved putting up new infrastructure for this. So we have installed these sensors in traffic signal cabinets. So there's no capital outlay in putting a new structure so that we can put this. So it's just utilizing existing infrastructure. That's one of the lessons that we have learned.
Yeah, and look for the champions in your organisation or in the wider community, because they'll do a lot of the heavy lifting and they'll get extra buy-in from the people that you need to get across the line. So find your champions and your allies and work closely with them.
Fantastic. Grace Leon, Michael Healy, thank you very much for discussing with us EQRNet Seismic Resilience as a Service.
Thanks, Chris.
Thank you.